let us continue our next part of electricity. In our previous videos or in our previous classes, we had talked about, just let me give you a short recap what we had talked about in our previous classes or previous lectures. First of all, we had talked about charge, then we had talked about current. Charge is denoted by, everyone knows, charge is denoted by Q. Then we had talked about current, that is denoted by I. Then we had talked about potential difference, that is denoted by V. Then we had talked about R, that is the resistance, and then we had talked about resistivity. Now, our next topic in electricity is combination of resistors. Children, in our suppose this is a simple circuit consisting of a battery, because it is a combination of two cells. If there are two or more than two cells, then this is known as a battery. If there is a single cell, then it will be a cell only. It is a then let us assume that we have connected an ammeter here. This is the positive end of the ammeter and this is the negative end of the ammeter. Then I have connected an appliance, you can say a bulb or anything. How will I denote that appliance here in my circuit? That appliance in my circuit is denoted by this resistor. So this is resistor. Now across this resistor we connect to the our voltmeter. This is the positive end of the voltmeter and this is the negative end of the voltmeter. Then comes our rheostat for the variable resistance, and then comes our key, plug key. This is open, key is closed, our circuit is complete, so the current is flowing through the circuit. This is a complete circuit diagram, children, consisting of a battery, an ammeter, resistor. Across the two ends of the resistor we have the voltmeter, then we have the rheostat, and then we have a plug key. Here the key is closed, that is why the current is flowing through the circuit. These arrows denote the presence of the current, or these arrows show that the current is flowing through the circuit. Now let us, if I have more than one resistor, see, if I have three resistors, R1, R2 or R3. Suppose in a room I have a fan, I have a bulb or I have a tube light. How do I want to connect them? This is only we are going to talk about in this video. Whether I am going to connect them in series or I am going to connect them in parallel. Generally in our household circuit, the setting is done in parallel combination. Later on we will talk about the parallel combination and its advantages over series. Today first we will talk about the series combination. Suppose there are three resistors. Now I want, what is the series combination, children? First of all, the combination in which the resistors are connected end to end. What do you mean by end to end? End to end means there is resistance R1. I want to connect this resistance. If I bring this resistance here, this is my R2. I have taken this here and I want to take R3 also here. Now this is my R3. This combination of resistors, now these are joined end to end. The beginning point and the last point of resistance 1 is connected to the beginning point of resistance 2, and the end point of resistance 2 is connected to the beginning point of resistance 3, and then there is another connecting wire, or this way we can form a combination of resistors. Now let me draw a circuit diagram comprising of these three resistors. So first of all, let us draw a battery. This is the positive end of the battery and this is the negative end of the battery. Then comes our ammeter. Ammeter is always connected in parallel to the circuit. Then comes, suppose this is our resistance 1. Now here I have connected resistance 2. Here I have connected resistance 3. Alright, now I am not, suppose I am not connected the voltmeter here, then suppose there is no need of rheostat also. Let's continuously make the circuit very simple. Let us keep our circuit very simple. Now connect it with a plug key. As the key is closed, the current is flowing through the circuit. Children, I hope you all know that ammeter is used to measure the current and voltmeter is used to measure the potential difference, and potential difference is always connected in parallel to the resistors or the appliance across which we want to measure the potential difference. Suppose in this combination, in series combination, because these three resistors are combined end to end, so that is why this is the our series combination of resistors, series circuit. Children, this is very important derivation in the exam. These are mostly asked questions, commonly asked question I mean to say. It's very important question. Either in the exam you will be asked to derive about the resultant resistance of series combination or the parallel combination. Now what is resultant resistance? Suppose in this circuit I have connected three resistors, but I don't want to use three resistors. What will I do? In place of these three resistors, I want to put just one resistor. So in this combination of series combination of resistors, we are going to derive what will be the resultant resistance. Resultant resistance, if in place of these three I want to use one, then how will I come to know what is the total resistance of this? That we are going to find out at end. Now, suppose I connect a voltmeter here across this R1 between these 2 points. This will be giving me the value of V1. Again, I'll put another voltmeter here. I note down the reading. I get the reading. Suppose this is 18 volt battery, or you can say 6 volt battery. Suppose 6 volt battery. Now, again, I have connected third voltmeter here. This is V3. I have come to know when I joined these voltmeters across these three different resistors, I got the different value of V1, V2 and V3. Is that clear? Suppose when I put the voltmeter here across resistance 1, I got the value V1. When I put the resistor here, voltmeter here across R2, I got the value V2. And when I put this here, I got the value as V3. And when I combined, I found out that V, this is the total V. V is equals to V1 plus V2 plus V3. This is our equation 1. This is the first equation. And when I put the ammeter in this circuit, I saw there is a value. Suppose there is a value of 8 ampere in this. Suppose this is giving me a reading of 8 ampere. I put the ammeter first here. I got 8 ampere only. When I put the ammeter here between these two, anywhere you put the ammeter, suppose I put the ammeter here, I remove the ammeter from here, I put the ammeter there, I got a value of 8 ampere. Now I removed it from here, I put it here, again I got 8 ampere. Again I put here ammeter, again I got 8 ampere. This means the current in the series combination is always same. That is, I is same throughout the circuit, in series combination. Is that clear? We know that V is equals to IR. From where I have got this? From Ohm's law. Now, on applying Ohm's law in equation 1, applying Ohm's law, in equation 1, I got V is equals to IR. V is equals to IR. Then V1 is equals to IR1, because the current throughout the circuit is same, but across this resistor R1 the value of potential difference is V1. Similarly, across V2 I have got the value of IR2. V3 is equals to IR3. Now let me put this value in this equation. I get IR is equals to IR1 plus IR2 plus IR3. Now IR is equals to, I is common here, R1 plus R2 plus R3. Now let me cancel this I. That is R is equals to R1 plus R2 plus R3. That means in series combination, the resultant resistance is equal to the sum of the individual resistors. I'll repeat, children, in series combination, this resultant resistance is equal to the sum of the individual resistors. Suppose in this circuit, the same circuit, children. This is 6-volt battery. This is your ammeter. Sorry. Positive and negative end. Now, in place of using these three, if I want to use one resistance, what should be the value of that? That should be equal to the sum of these three resistors. Suppose these three, R1 is of 1 ohm, R2 is of 2 ohm and R3 is of 3 ohm. When I combine, I get 6 ohm. That means instead of using three resistance of different values, if I use one resistance of 6 ohm, I will get the same reading. Then here we are going to use the voltmeter this way. This is how it goes. That means in series combination, the resultant resistance is equal to the sum of the individual resistance. This is all about a series combination of resistors. In our next video, we will talk about the parallel combination of the resistors. Thank you, children.